Okay, so in the last video, we talked about what passive transport is. There are a couple of different types of passive transport. One of them was diffusion, which the last couple of slides talked about. Another type of passive transport is osmosis. Osmosis is the movement of water across a semi-permeable membrane. And because osmosis is a type of passive transport, that means that it is not going to use it's not going to use energy. Because osmosis does not use energy, that means it is going to flow from an area of high concentration to an area of low concentration of water. Now, before we get to this area down here, I want to talk about a couple of terms. So off to the side of your paper, write down these three terms. The first term is solute. So solute are the particles. This is what is being dissolved. The second term is solvent. Solvent is what is doing the dissolving. So this is the liquid. Most of the time it's water. The third term, solution, is a mixture of the two. It is the solvent and the solute together. So a way to think about this is like Kool-Aid. So your little Kool-Aid powder you have, that's your solute. It is the particles. It is what is being dissolved. Your water is the solvent. It is what is doing the dissolving. And your solution would be like your Kool-Aid all made together. So you've got the powder in there, you've got the sugar, you've got the water all mixed up, and it's ready to drink. That is your solution, the mixture. Let's talk about these three terms here: hypertonic, hypotonic, and isotonic. So hypertonic means more solute, less water. Hypotonic means less solute, more water. And isotonic means equal amounts of solute and equal amounts of water. So if we look at the prefix of these, we can kind of guess what it means. So hyper means more solute. Hypo means less solute. And iso means equal solute, equal water. So let's talk about a situation to where we would see these terms. So off to the side, I'm going to draw this beaker. Excuse the very, very bad drawing. So here's my beaker. It is full up to here of water, my solvent, or I guess my solution, I should say. And then I drop a cell into this beaker. All right, so when we would see hyper, hypo, and isotonic. So a lot of times when it's talking about hypertonic, hypotonic, and isotonic, you have to pay attention to what it's talking about. Is it talking about the solution in comparison to the cell, or the cell in comparison to the solution? So for this example, I'm going to talk about the solution, so the liquid, in comparison to the cell. So let's say my hypertonic solution, so it has more solute, less water. So I'm going to go ahead and do that real quick. So let's say I have 90% solute. I'm going to represent that with I'm going to represent solute with an S. So my solution, so the liquid outside my cell, is 90% solute. That means that the water has to be 10% because the solute and the solvent have to equal to 100. So 90 and 10 equal to 100. So that is my area outside the cell. Okay, so inside the cell, let's say I have, let's see I have 80% solute. And let's say I have, so if I have 80% solute, that means I have to have 20% water, because 80 and 20 equal 100. Okay, so this is considered a hypertonic solution. So solution, I'm talking about the mixture outside the cell. And it's hypertonic because I have more solutes outside the cell than what I do inside the cell. So I have 90 outside the cell, and I only have 80 inside the cell. So the thing you need to know about water, it always flows to wherever there is more solute. Water loves solute. That's the direction it's always going to flow. So I compare these two solutions here. So 80 and 90. So 90 has more solute, so the water, that's going to flow outside the cell. It's going to go outside the cell because it's going to wherever there is more solute, which is outside the cell. So the water will go out here because it's trying to equal out the solute. And because water is leaving the cell, what's going to happen is that the cell is going to shrink. It's going to shrivel up. So that it would be a hypertonic solution where there is more solute outside the cell than what there is inside the cell. Let's talk about a hypotonic solution. So again, I'm going to draw a beaker. So there's my beaker. And it's full up to this amount of water. And here is my cell that I dropped into this beaker of water. Okay, so a hypotonic solution. So that means that there is less solute and more water. So I'm going to make this, let's say this is going to be 75% solute. So I'm just using S to represent that. And so if it's 75% solute, that means it has to be 25% water. Because remember, the solute and the solvent have to equal 100. 75 plus 25 gives me 100. So this is my area outside the cell. This is my solution. Okay, so let's say this is 80% solute again. 80% solute, and again, if that's 80%, that means it has to be 20% water, because 80 and 20 equal 100. Okay, so when I'm talking about a hypotonic solution, I'm saying the solution in comparison to the cell. So I compare these. So the cell this time has more solute than the outside. So the outside has less solute than what is inside the cell. Because the solution has less solute than what is in the cell, it is a hypotonic solution. Okay, and in that situation, where you have a hypotonic solution, so remember, water loves solute. It's going to flow wherever there is more solute. In that case, that's inside the cell. So the water is going to flow into the cell. Because of that, this cell is going to swell up. It's going to get bigger because it's being filled with water, kind of like a water balloon. So that is a hypotonic solution, where you have less water, where you have less solutes than the other part you're comparing it to. Less solutes in the solution than what I have in the cell. Let's talk about an isotonic solution this time. So remember, isotonic is going to be when you have an equal amount of solute and an equal amount of water. So again, I'm going to draw my beaker out here off to the side. Oops. And my beaker is this full of water. And then I dropped a cell inside of my beaker of water. Okay, so again, isotonic is equal amount of solute and equal amount of water. So my solution here, the area outside of my cell, let's say that has 60% solute. And if I have 60% of solute, that means I have to have 40% water. Because remember, the solute and the solvent together have to equal 100. 60 and 40 give me 100. All right, and in our cell, let's make the solute amount 60 as well. And then again, because I have 60% solute, that means I have to have 40% water. Because again, 60 and 40 give me 100. My solute and my solvent have to equal 100. Okay, so I have an equal amount of solute in the solution as I do inside the cell, and an equal amount of water outside the cell and inside the cell. Because of this, the cell is going to stay the same. Now, that doesn't mean that water is not going to move. Water is still going to move. It's just going to move in and out in equal amounts. So how I represent this is I'm going to draw an arrow pointing in and an arrow pointing out to represent that water is still moving. It's just moving in and out at equal directions. Or you can do this little thing here where you have a double-sided arrow. So that's isotonic, when you have equal amount of water and equal amount of solute inside the cell as well as outside the cell.